Hi, I am Syed. In the previous video, we have seen particular integral of exponential function. In this video, we'll try to continue few problems on particular integral of exponential function. Let us move on to the next question. Solve y double dash plus 2 times of y dash plus y is equals to this cos h x by 2. So we can write this in the form of the operator. So d square plus 2 times of d plus 1 times of y will be equals to it is cos h x by 2. So once again we'll write down the auxiliary equation. It becomes m square plus 2m plus 1 is equals to 0. This equation is nothing but m plus 1 whole square form. Therefore the value of m will be equals to minus 1 comma minus of 1. Or if you want to use your calc, you can choose mode 5 for equation, then option number 3, then the coefficient of m square will be 1, then the coefficient of m will be 2, the constant term will be 1. Just see the roots, so you can see that the root is minus of 1, the first root, whereas the second root is not shown, which means that minus 1 is being repeated twice. So those are the roots I have written over here. So if you write down the complementary function will be, since the roots are repeated, we write down c1 plus c2 x into e power of minus 1 times of x. So that will be the complementary function. Now let us write down the particular integral. So if you want to write down the particular integral, because it is in the hyperbolic function, you have to write this hyperbolic function in the form of the exponential function. So we know this formula. It is cos h ax. So the standard formula that we have is e power of ax plus e power of minus of ax divided by 2. So now if I use this formula for cos h x by 2, right? So here the value of a in this case is a will become half. Coefficient of x will be half. So if I write down, this becomes e power of x by 2 plus e power of minus x by 2 divided by 2. So that will be cos h x by 2 value. So now if I write down the particular integral will be 1 by the operator, right, d square plus 2d plus 1 times of the right hand side value, it is cos h x by 2. So but the value of cos h x by 2 has been obtained over here. You can write down it is 1 by d square plus 2d plus 1 times of it is e power of x by 2 plus e power of minus x by 2 whole divided by 2. So let us try to simplify this one. So because 1 by 2 is a constant, I will take that 1 by 2 outside. Now because there are two terms, I have to apply this operator for the first term separate as well as for the second term separate. So let us multiply this with the first term. I will be getting 1 by d square plus 2d plus 1 times of e power of x by 2 plus again multiply this operator with the second term. You have 1 by d square plus 2d plus 1 into e power of minus x by 2. So you can observe over here, because it is in the form of 1 by f of d into e power of ax, you have to replace the value of d by a. So in the first term that you have, we will try to replace d as a. So a value in this case is coefficient of x is 1 by 2. Whereas in this case, we will try to replace the value of d by what value? Coefficient of x will be minus 1 by 2. So it is minus 1 by 2. So therefore the particular integral will be equals to 1 by 2 as it is. So wherever d is there, just replace that by 1 by 2. So it is 1 by 2 whole square plus 2 times of 1 by 2 plus 1 times of e power of x by 2. plus 1 by. So in the second term you have to replace the value of d by minus 1 by 2. So it is minus 1 by 2 whole square plus 2 times of minus 1 by 2 plus 1 times of e power of minus x by 2. We can evaluate this one. So pi will be equals to 1 by 2 times of. So it is 1 divided by. So this becomes 1 by 4. This 2 and 2 will cancel out. This becomes 1. So 1 plus 1 will become 2. This is e power of x by 2 plus it is 1 divided by minus half square will become 1 by 4. This 2 and 2 will cancel out. This becomes minus 1. So minus 1 plus 1 will also cancel out. It will just be 0 there. Minus 1 plus 1 will cancel out. And you are left out with e power of minus x by 2. Or this will be equals to 1 by 2. So if you take the LCM and simplify this value, 1 by 4 plus 2. So you will be getting how much? 9 by 4. Just check it. So if you take the LCM, it will be 9 by 4. So it is 1 by 9 by 4 into e power of x by 2. Here 1 by 4, if I take it in the numerator, it becomes 4 times of e power of minus x by 2. So it is 1 by 2. Once again, here also you can take the reciprocal as it becomes 4 by 9 e power of x by 2 plus 4 times of e power of minus x by 2. So if you take 4 common outside, you will be left out with 1 by 9 e power of x by 2 plus e power of minus x by 2. So what happens is this will cancel out, we will get 2 times. So it is 2 times of 1 by 9 e power of x by 2 plus e power of minus x by 2. So that is the particular integral you have. If you want to multiply the expression, you can just multiply. It becomes 2 by 9 e power of x by 2 plus 2 times of e power of minus x by 2. So now you can write down the solution, y to be equals to the complementary function plus the particular integral. So y is equals to the complementary function that you have got is c1 plus c2x into e power of minus of x, and this is your particular integral 2 by 9 e power of x by 2 plus 2 times of e power of minus x by 2. So that's the required solution.